Hey, welcome again to the CTO Advisors coverage of SAP Sapphire 2019. We have a treat for you. We're going to go into a topic that we don't normally go deeply into, ML, machine learning with GP. GP, you're a data scientist at Accenture, right?
Yes.
Really appreciate you coming onto the show. You have an upcoming book on ML, AI. Give us the overall impression of the show, kind of what your research has been and how it relates to the conference.
Sure. Deep reinforcement learning is the most advanced machine learning technique. That this particular type of algorithm has completely off the charts. It's on the top of the technology right now, and like the Brain Institute in the past decade has invested more than $1 billion to understand how the neural networks operate in the brain and how the consciousness powers the coordination of all the neurons in the human brain, because there are around 87 billion neurons in the human brain, and when a decision emerges out of the brain, it's so synchronous and it's so simultaneous, and it just goes through all the neural paths and goes through the synapses and sends the signals out and then connects that, and it provides a decision. The reinforcement learning is definitely based on the same architecture.
Right.
Basically what it does, for a robot to basically, for example, to come out of a maze, there could be several paths and there could be several states, and the robot has to perform a specific action to come out of the maze. And the reinforcement learning does that. It goes through multiple episodic training of the algorithms, and it produces the action that is required in a most optimal path to come out of a maze. There could be several environments like that, like OpenAI, GYM. Once we understand how all of these neurons operate together, and we can actually compute that into a neural network, then we can find out the paths for these neurons, and how does that decision emerge from the neural paths. And that's what this leads to, the AGI. And other than the OpenAI GYM I was talking about, I leverage a lot of OpenAI GYM environments for the implementation of this reinforcement learning algorithms. Also, like DeepMind has come up with their own lab of environments for reinforcement learning. And there are a few other companies who are also implementing this reinforcement learning for the artificial general intelligence.
So let's talk about like the current state of the technology. So there's the neural networks and leveraging neural networks and this reinforcement learning technique. How can companies apply that to AI ML today in some of their decision processes?
So most of the artificial intelligence machine learning techniques that the corporations apply are based on the historical data sets.
Right.
So what they do is they take a lot of historical data, and then the machine learning algorithms simply learn from the data, and then they produce the outcomes in terms of like predictive analytics or advanced financial forecasting, those type of applications corporations are building. But
so today, so that I understand
that's
that.
yeah.
So today, you know, Intel gave us that a couple of weeks ago, or a few weeks ago at their data-centric event, that said that only 2% of the world's data has been analyzed that has been generated in the past 5 years. So that's a tremendous amount of data, but the way that we're doing ML and AI today, we take that data, see patterns in that data, and then we can make decisions or predictions based on that data today. That's a pretty common use of AI. However, what sounds like what you're talking about for reinforcement AI is a little bit more free world.
Exactly.
And looking at the
Yeah. So because it does not require any data at all.
Right.
It's just like a human decision, right? Because like a human makes a decision, a dynamic decision, like let's say a car has to go onto a mountain, and then it's challenging because of the uphill task, and either the person has to throttle or go in the right direction or left direction to balance out the car and reach to the top of the mountain. And that doesn't have any
You've not seen the mountain before.
There's no data. Exactly.
Right. You kind of, as a human, I kind of intuitively know
exactly
how to navigate the mountain.
Exactly.
And so teaching neural networks how to do that same thing is the goal. What's the key indicators that we're starting to know that we're making ground in these areas?
So we have seen some significant improvements and achievements. Like on the chess, where like the machine has totally has beaten the humans in terms of the chess, and we also have seen a few other, that was AlphaGo, and a few other instances where we have seen some of the gaming environments also have shown significant improvements in terms of operating it through artificial intelligence, applying the reinforcement learning. Like Mojako environment is a environment, it's a gaming environment. And so there are a few other environments where we have seen that kind of a pattern where the reinforcement learning completely operates on its own, does not have any historical data set. It basically goes through episodic iterations. For each iteration, it gets some rewards for doing it right.
Right.
And then there will be a discount factor on the reinforcement learning, how much has been the reward versus if there is any loss. And there are also value approximation functions that can calculate the reward. And then finally, when we get the output, it's basically an action to be performed. And that's what is needed to accomplish the AGI, because most of the time we see like autonomous vehicles operating on the road, and then again there are pedestrians crossing the road, and it does not know whether to save the passenger or to save the pedestrian.
Right.
That is an action that it has to make instantly, right on the spot. It's not like something it has to have some data for it. It's a dynamic decision.
And humans struggle with some of these decisions ourselves. So
exactly.
The ideal of the concept of rewarding, during the learning phase, the concept of rewarding the algorithm for making certain decisions, I have to imagine a lot of the difficulty is in, to your point, is the AI making the decision based on the reward, or because some other factor, kind of getting those knobs right?
Yes. So that's what the reinforcement learning does. It doesn't have any data. It just has to perform a dynamic action in a number of states. And there could be so many states of it. Like, for example, when it's navigating through a mountain or it's navigating through a road, there are several states for it. And again, some of the objectives have been fulfilled through like sensors like LIDAR, for example.
Right.
Laser light range detection technique, or radar sound technique, where it senses the movement of people around the car, and then basically it finds that these objects are there, and then it kind of navigates through that. This was actually implemented on Mars by NASA before for the Mars rover vehicles, and Mars rover. And so the way they calculated it is because of finding the motion of an object, and is detected by the vehicle, and then it can apply some SLAM algorithm, and then it can navigate through that. So these type of decisions are like, for example, for any like a shuttle to land on a Mars, it doesn't have a prior.
It's Mars.
It's different environment altogether.
Exactly,
I mean,
right.
We cannot predict like how it's going to land there.
And because of latency, we can't put a human remotely to navigate. So there has to be some type of AI to navigate and make decisions.
Exactly, and that's what I'm trying to do in this book. Basically, taking multiple environments It could be a gaming environment. It could be like a mountain car. It could be Acrobat. Different types of gaming environments, and how it, or even if it could be a simple traffic problem. So as I was explaining about different algorithms for reinforcement learning, like trust policy, region optimization algorithm, and policy gradients. So there are several recipes that I'm developing for the book, and the book will be called PyTorch 1.0 Deep Reinforcement Learning
Okay.
Cookbook. And it will cover, there will be like 100 recipes in it, and each chapter will explain a snippet of code, how to implement these algorithms, and how to implement each methodology for most optimal path and optimal strategy to resolve and solve the environment.
And when do you expect the book to be released?
Well, we were actually it was supposed to be released in May.
That's how books go. Yeah, right.
I could only complete like 3 chapters so far. We are expected to complete like 10 chapters.
Okay.
And so, I mean, I haven't completed all the rest of the 7 chapters yet.
That's okay.
So,
and do you participate on social media, Twitter, or
Yeah.
What's your Twitter handle?
My Twitter handle is GP_PULIPAKA.
Mm-hmm.
And I share lots and lots of content on reinforcement learning and different machine learning techniques, how these have been deployed by different companies on the production landscapes, and how it benefits, and what are the most optimized ways of doing it.
So GP, I really appreciate you coming on to the CTO Dose. If you made it this far, you are a ML AI geek, and we really appreciate you guys turning into the CTO Advisor. We have other enterprise related content. You can find that on the web at thectoadvisor.com. You can follow me on Twitter at CTO Advisor. Talk to you next CTO Dose.